Welcome to day 27 of our school year. Let's go ahead and fill that in. And let's do our starting fraction. Our starting fraction is our total amount of school days, which is 180. And we are on day 27. So we're going to find the factors of our numerator, which is 27. Two factors we always know are 1 and the number itself, and then using the commutative property of multiplication, 27 times 1. Now I'm going to try to figure out the rest of my factors using my divisibility rules. I'm going to go in an orderly fashion. That means I'm going to go try every number in order to make sure I don't miss any. So after 1, I try 2. The rule for 2 is that it ends in an even number. It ends in an odd number, so 2 is not a factor. If 2 is not a factor, that means no even number will be. So I don't have to try 4, 6, 8, any other even number, because if 2 doesn't work, none of those will work. So now I'm going to try 3. The rule for 3 is that we add the digits together. 2 plus 7 equals 9. 9 is a multiple of 3, so 3 is a factor. 3 times 9, 9 times 3. So all I need to do is check the odd numbers between 3 and 9. So our next odd number is 5. The rule for 5 is that it ends in a 0 or 5. It ends in a 7, so 5 is not a factor. We try 7. We list the multiples of 7. 7, 14, 21, 28. No, 7 is not a factor, but it will be on our next day. So we get to 9. We are done. Let's list our factors from least to greatest. 1, 3, 9, 27. We have 4 factors there. 4 is more than 2 factors, so it is composite. So now we need to figure out which one of these is our greatest common factor. So let's start with our greatest factor and see if that's also the greatest common factor for 180. So we try 27. Remember, it doesn't matter what your groups look like, just as long as you have 27 in each group. And you don't have any shaded with unshaded, so just go ahead and put your group of shaded into a group of 27, and then we'll go from there. So I said 3 times 9 is 27, so I see 3 here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 groups of 9 is 27. You can check. 3, 6, 9, 12, 15, 18, 21, 24, 27. Every time you multiply, you make a rectangle. So I could use those multiples to help me out. Let's see. 3 times 9. 3 times 9. And here I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I take these 3, 9, 10, 11, 12, plus this, it's going to be 22. And I'm still going to need 7. Sorry, I'm going to still need 5 to get to 27. So 10, 13, 18, 19, 20. 20, 21, 22, 23, 24, 25, 26, 27. Okay, so I have 5 here. Plus 10 is 15. Plus 10 more is 25. Plus 2 is 27. And it looks like I have 18 left over. So that means 27 did not work, because you can't have any left over for it to be a factor. So that means I'm going to try 9. So we're going to make groups of 9. Make sure you keep the shaded and the unshaded separate. So I have 2 groups of 9 there, and then I have 2 plus 7. So make sure you make your groups of 9, your groups of 9 in your shaded area first. Then you go back and you make your groups of 9 in the rest of the area. Now 9 is actually a perfect square, so I could use perfect squares to help me with making groups. It's called a perfect square because it's a 3 by 3. 3 times 3 is 9. Those sides have the same factors. Or I could count down 1, 2, 3, 4, 5, 6, 7, 8, 9. And make sections that way. You could just count and make your groups. Look for patterns. Look for some logical ways. Use your number sense to help you figure it out. Those are all mathematical practices. Right, so here I have 7, 2. I have 5 and 4. I have a perfect square. I have 8 plus 1. And then 9. So your groups may look very different than mine, but you should, each group, if you count it, must have 9 squares in each. And you must keep the shaded in separate groups from the unshaded. It looks like 9 worked. I had none left over, so that means 9 is my greatest common factor. So let's go ahead and see how many total groups of 9. That's our new denominator. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 total groups. And I have 1, 2, 3 groups shaded in. Okay, now let's look at our algorithm, because we've just did our division with our model, because dividing has to do with making equal groups or repeated subtraction of equal groups. And so I am now going to use my algorithm to prove it in a different way. I'm going to divide both by my greatest common factor of 9. Let's see, I'm going to start with 9 times 10, because I like multiplying by 10. Just moves everything over a place, because every place is 10 times greater. So 9 times 10 is 90. Number's the same. 0's a game. And then here, this is just 18 take away 9. 18 take away 9 is 90. Well, I know how to get 90. That's 10 times 9. 10 times 9 is 90. Number's the same. 0's a game. Add these together. 10 plus 10 is 20. Okay, let's see. I know 9 times 2. I'm pretty good at my 2. So 9 times 2 is 18. More on the floor. Go next door. Regroup 10 more. 17 take away 8 is 9. 1 take away 1 is 0. Oh, I know how to get 9. 1 times 9 is 9. Number's the same. 0 is the game. Add up my partial quotients. 2 plus 1 is 3. Now I need to check my answer with my inverse operation. Divisor times quotient plus remainder. Divisor times quotient plus remainder. Now on both of these, my remainder is 0. And the identity property of addition says when you add 0, it just stays the same. Since it's just going to stay the same, I don't need to take the time to add it. 9 times 0 is 0. 9 times 2 is 18. 9 times 3 is 27. 180 matches my dividend up here, so that checks. 27 matches my dividend up here, so that checks. That means 3 is my new numerator and 20 is my new denominator. But 20 is one of those special numbers that I can actually easily turn into 100 through multiplication. So we're going to look at our per means through, cent means 100. Per 100, we're going to look at our percent. To get 20 to be 100 through multiplying, 20 nickels makes $1. So 20 times 5, or 5 cents, would give us 100 cents, or 100. 3 times 5 is 15. 20 times 5 is 100. So we have 15 hundredths, which looks like this is a decimal. Let me write it down a little bit lower. Like 15 cents. They're called cents because there's 100 of them to make $1. So 15 hundredths, or 15 cents if it were money. And then that's 15 per cent. So we have completed 15% of our school year, and we have 85% of our school year left. Okay, let's go ahead and fill in our data collection page. Right, we are in trimester 1 still. We are on week 7 now. Today's date, we have 9, 16, 19. And our fraction for today, let's write it really small. We got a few things to fill in. We have 3/20ths, which is equal to 15 hundredths, which is equal to 15%. So we've completed 15% of the school year. That means we have 85% left to complete. Let's go ahead and get out our number line. So we did groups of 9. Okay, so we have 1/20th, so we need 2/20ths. That's equivalent to 1/10. That was our simplest form. And today is 3/20ths. Nothing below it, but we do have an equivalent fraction in the 3's, and then here 27 180ths. So 3/20ths is our simplest form, or equivalent fraction in lowest terms. Go ahead and put your number line away, erase your worksheet, and thank you for joining me.